Okay, so welcome to day two of the class and objects in Python. Okay, so yesterday, we saw how to create a class, correct? Um, we even saw how to write the four different types. Okay, how to add four different types of members, right? Um, your class um, um, your class level variable, class level method, right? Object level variable and object level method. So what we saw that we declare a variable within the class to call it as class level, right? And we used a one second. Okay, so we saw how to create a class, correct? And we saw how to add four types of members, and we also saw the usage of init, isn't it? What is init? Init is a default method which is called automatically. Okay, when we create an object, we don't have to call the init. Okay, so generally, if we have to initialize any member, if you have to initialize any member or any variable, we put it in the init class. So today I'm going to just show you how to write a simple program using class. Okay, so program to implement addition, subtraction, okay, multiplication and division. Okay, we'll write a simple class, okay, to implement this. So you will see how data flows from one object to another, what is the usage of init and other things. So I just said, now that you know how to use class and objects, we should try to use class and objects as much as possible. Okay, we should try to use class and objects as much as possible. Okay, so I'm going to call this as class what do you call arithmetic operation, say arith op. Let's say this is what we call it. Okay, and we will define init function, and here we will take two numbers. We call it as n1 comma n2. Okay, and we will have two variables n1. Now we are writing same name, okay, n1 and n1, but they are different. They are not same name. They are different names. Self dot n1 is different than just n1. Okay, so self dot n2 equal to n2, right? So this is your init. Now I'm going to say def say add, right? Now you see it automatically added self here, and I'm going to say return self dot n1 plus self dot n2. Okay, we don't have to pass the value here because since add and init belongs to same class, okay, it knows what n1 is, self dot n1 is, and self dot n2 is. It doesn't know what n1 and n2 is, but it knows what self n1 and self dot n2 is. Okay, and we can add other four or operations as well, right? So we said addition, subtraction, multiplication, and division, right? And we'll say n1 minus n2, n1 into, sorry, n1 into n2, and n1 by N2. Okay. I think we got it. Yes. Now you simply say arithmetic A1 equal to arith op. Now for this arith op, we have to pass values for N1 and N2, isn't it? So let's say here I say 20 comma 10. Okay. Now, see, these functions are only returning, they're not printing, right? So if I have to call this function, I would rather save it in a variable and then print it or directly print it. Okay, so I'm going to say print addition A1 dot add. Correct? Now I can create another operation, sorry. So I'll say A1, A2, A3, A4, and 2010, 210, 120, 110, 520, 110. Okay. So A1, A2, A3, A4, and I'm going to say addition, subtraction, multiplication, division, right? And what I'll do, I will call different objects A1, A3, and A4. Okay. So see, addition, I'm calling 20 and 10. So you get 30. Subtraction, I'm calling A2, which is 200 minus. Oh, I did not change this, right? So what did I put? Sub and mul. Sub. Here you put multiplication. And here I'm putting div. Okay. So you see, addition is 30, 20 plus 10. Subtraction is 200 minus 10, right? Multiplication is 120 into 110. And division is 520 divided by 110. Okay. So this is how, classes knows how to specifically look for specific values. Okay. So the values that we give is added to the specific object. Okay. All good so far? Okay. If this is good, we will move to the next part, which is called the properties of class and objects. What are different properties of class and objects? Okay. So the different properties, okay. Properties of class and objects. Okay. The most important property is called inheritance. It's called inheritance. Okay. Called polymorphism. Okay. Then it's called abstraction. Okay. And then you have encapsulation. Okay. Okay. So there is a meaning associated with each of these. We'll start with abstraction. Okay. The third one. Abstraction means the implementation is hidden from you. Okay. Implementation is hidden. Now, as a user, okay, we are only using the object A1 and we are saying A1 dot add. We don't need to know and we don't have to know how it is implemented. That's called abstraction. So generally, if you see in the book, they'll compare with this with example of a car or your bike, for example. Okay, you have accelerator, you have brake, right? You have clutch, you have gear. Now to to drive, okay, your car or two-wheeler, you don't need to know what happens when you press accelerator. When you give accelerator, what happens inside, how the fuel goes, how the engine works, we don't have to know, right? To drive a car, you don't need to know how things work. You just need to know, okay, this is what happens if I put a brake, vehicle stops. If I put accelerator, it starts moving faster, right? You don't need to know how all those things work together. Of course, the mechanic or the manufacturer of the car, they should know all those things, right? So it makes it easier. Imagine if you had to understand the concept of what happens, how engine works to drive a car, then 50% of us probably would not have driven the car, right? It's so easy. You just hold the steering, you apply your feet on those things and it works, right? So just to show you that, okay, as a user, okay, when you did list or when we did dictionary, okay, we didn't have to get into details. We didn't have to worry about how append worked or how copy worked, right? Okay, we want to do this, okay, call this function and work is done, isn't it? We don't have to worry about the implementation details. That is called abstraction. And all the other things, okay, is a way of abstraction, in the sense, I'm going to talk about other things as well now, but you know that as a developer of class, you need to know how to write all these functions, how to make sure that append works correctly, make sure that your copy works correctly, make sure your upper lower works correctly. But as a user of the class, we don't need to know. So when you put your hard work and you declare it, the users of your class, okay, will find it very easy and very intuitive. Intuitive in the sense, when we say append, okay, logically append means to add, correct? And it was able to add it. So the user, okay, it's not that when you say append and it elements got deleted, right? So we make it so easy for the users of the class, okay, or who is going to use the objects of the class, okay, to use these functionalities or these features with ease, right? That is called abstraction. You hide the implementation details. You said, okay, you want to append something to list, use up list.append. That's it. You don't have to worry how it worked in the background. It could be one line code, it could be 500 lines of code, right? Okay. So that is called abstraction basically. And all the other features that we're going to talk about is a way of abstraction. Okay. You're abstracting the details from the user. Okay. The second, okay, we'll talk about inheritance and we will see some examples of inheritance. Okay. So inheritance is a class inheriting properties from another class. Okay. So you have a class which inherits the properties from another class. Okay. So for example, let's say we declare a class called fruits. Okay. So you have a class called fruit. So can you tell me some properties of fruit class? So fruit class can be, eating, correct? You eat fruit. Now, putting it into salad, we don't put all the fruits into salad, correct? So putting into salad may not be property of fruit. Next, we create a class called apple. So logically, class apple is a subset, or is a class which belongs to the proper fruit class. It should technically belong to fruit class. So when we say, okay, we eat all the fruits, and if I tell you that apple is a fruit, that technically means the apple can also be eaten, you don't have to specifically mention that apple can be eaten, right? You have mentioned at a high level, at a fruit level, that we eat fruit, right? Then we don't have to mention at apple level again that we eat fruit. So what it means that you are inheriting the property of your parent class. If fruit is parent and apple is child, you are automatically inheriting the properties of your parent class. So that is called as inheritance. You inherit the properties of your superclass, okay, parent class. We call it as, okay, superclass or base class, okay, or parent class. So you don't have to specifically write again the same property. Okay. Polymorphism means multiple forms. Okay. Now, if you remember, okay, your plus sign that we used, right? So when you say 5 plus 3, it gave you 8. When we added to list, it added to list. It added to string. Now, it's the same plus sign, okay? 5 plus 3, right? Print hello plus there, right? So if you run it and see, okay, they're performing, okay, it's the same plus. Are they performing same role? No, right? Adding to number is different than adding to string. They are not same, right? But we are using, okay, you are using, okay, it to perform more than one operation. Okay, so same property can be used to perform more than 2 operations. This property exists in Java also. In Java, generally, it does a lot more. But in Python, thankfully for us, because, if it were bigger, we would have to learn more, right? Right. So, it has said few things about it, which, of course, when we start doing it, okay, you will understand it better. But for now, it's good to know that you can have different forms of same property. Okay, so same name can be done in 2 different ways. Okay, like copy, for example, if you have seen, copy was in list also, copy was in string also, right? Definitely, it's not same copy. It's not same because one is taking input as list, another is taking input as dictionary. So it cannot be same logic that is written. But name is same, so the operation, the performance is similar, right? For example, here, performance is similar. We are putting 2 things together. But obviously, the code for this plus and code for this plus, the inbuilt code that is there is different, obviously. So they have different operations, but same name. For example, okay, real life, if you have to think, you have to say registration. Now, registration for examination is different than registration for a dance class, is different than registration for a something else. But the meaning doesn't change, right? When you say registration, you have to register for it, right? So it's not saying, we don't say registration for dance class is registered dance, registration dance, registration for painting class is registration painting. No. Okay, they are different process. But since we are doing similar activity, we give same name. So it's called polymorphism. Same name, but multiple different operations it's performed. So in a way, this is also form of your abstraction only. Okay. Okay, the details are hidden from us. Okay. So of course, as I said, plus for integer is different. It has a different code inside, and plus for text has a different way of implementing, but it's hidden for us. What we just see is the output, right? So 2 different code, but we see single. For us, it looks like as if this is only one thing. Only one plus is doing this also and other thing also. That's called polymorphism. Okay. And then we have encapsulation. Okay. So encapsulation, okay, is again similar to abstraction. Difference being, in abstraction, we are hiding, okay, implementation detail. Implementation detail, right? This is what we are doing, right? We are hiding implementation detail. We don't know how it is implemented, but you just use it. We don't know how append is implemented, but you just use it. Encapsulation is hiding information. Okay, hiding information. Okay, so um, how do you um, how do you implement inheritance? How do you implement polymorphism? So implement inheritance and polymorphism using abstraction and encapsulation. Okay, so you're hiding the details and you're also hiding the information. Okay, so for example, okay, in this example itself, I told you, as a child class, you can inherit the properties from your parent class, right? Apple will inherit properties from parent class. But let's say parent doesn't want child to inherit the property, right? Okay, so parent class says, no, I don't want my derived class. Okay, so you have base class and derived class, parent class and child class. Okay, super class and subclass. So we generally use base and derived. Okay, base class and derived class. So what we are saying is that base class doesn't want its derived class to access the properties. We do not want base class to give or expose its properties. Then it can hide the information. So the encapsulation is in a opposite of inheritance in a way. Inheritance is then when you want parent class to give access to the derived class. Encapsulation is no, I don't want to give. Okay, so we will be using all of these things together actually. Okay, so with that, let's see some examples. So we'll start with inheritance. Okay, and slowly we will see all the other properties as well, right? Okay. So, okay, let's start with inheritance. Okay. I'm thinking, can I reuse the same class? Okay, so you have arithmetic operation. Now, let's say you have arithmetic operation and this is as your high level operation, addition, subtraction, multiplication, division. And we will have square and square root. But square and square root is not part of arithmetic operation, it's part of math operation. Okay, so I will say here class math operation. Okay, class math operation, and I will define init square root and square, right? We just need one value n1. So we'll say self dot n1 equal to n1. Now I'm going to define value square. Okay, and it says return self dot n1 into 2. Define value square root. Okay, Okay, so let's complete this second function. I'm saying here we are returning self dot n1 into 0.5. That's the square root thing. Okay. So now you see these are two different classes, right? There's no linkage between these. Okay. So these are two different classes and there's no linkage between math hop and arithmetic hop. So then if this is the case, okay, then as a user, okay, if you have to use it, let me put this in the starting. Okay. And let me delete it for now. Okay. So as a user, okay, as a user of these classes, okay, you can create object of object of arithmetic op, arith hop, A1, A2, A3, right? And this will only have addition, subtraction, multiplication, division. It will not have access to your square root and square. So to create square root and square, I have to say B1 equal to what is the class we created? Math op, right? So I'm going to say math op, correct? And you pass a value 50 here. And now you will have access to B1 dot square root. Okay, so I can say print square root. Okay. And print square. Right? So you say B1 dot value square, correct? And now you get square root of 50 and square of 50. Okay. Okay, fine. But as a user, you have to remember, oh, okay, for addition, I have to do arithmetic op, for square root, I have to do math op. Instead, why don't we put math op also inside arith op or arith op inside math op? So we'll say that base class is math op. Okay. So since base class is math op, I'm going to copy this and put it in the beginning. So this is like parent class. So math op is parent class. And now arith op, okay, will become the child class. Now, how do you create child class? So to create child class, we put a bracket open and close, and you put the parent class name. So I'm going to say math op. Okay. So what I did, I'm saying arith op is child of math op or derived class of math op. Math op is parent or base class. Okay. Higher level is math, lower level is arithmetic. Father is math, father or mother you call it. Child is arithmetic. Parent is math, child is arith. Okay. So now what happens? Okay. All the properties of math is available to arith op. But there's a challenge here, we'll see later. But so when you run it, okay, you can continue to run them separately. Okay. If I know that, oh, something called arithmetic op exists, I can use arithmetic op directly. I don't have to use math op in order to use arith op. But in such cases, what we do, we don't expose arith op. Why? Why should user know that we have implemented these three in arith op? So here itself, if you say B1 dot, now you see B1 you have access to val1 val thing, correct? Now, if I use, because child class is arith op, right? Child class is arith op. So child class will inherit the properties of parent class. So parent class is math op. So B1 does not have other functions access. You only see val square and square root. Okay. So see, parent cannot inherit the properties from child class. Base class cannot take the properties of child class. Only child class can take the properties from parent class. So B1 will only show you two properties. But the moment I say A1 dot, so A1 will have addition. Okay, you have sub, you have div, you have mul, and you see, you also have square. Make sense? You also have square. And what is the beauty of this? So if I go and copy paste this here, and I'll put A1, right? I'm saying A1 because A1 is object of arith of, and arith of is the child class. So child class will have the properties of parent class also. So now when I say A1 dot val square and A1 dot val square root, these are accessible. Now if I run it, do you think you'll get the answer? Of course you get the answer. A1, we are giving N1. See, here, luckily, we are using same name, N1 and N1 here. So when you are using arithmetic op and you're passing N1, N2, okay, and then when we are calling square and square root, we are using N1. So it's like, okay, in this is like as if this got copied and pasted here. Though we are not pasting it, we are not duplicating. Never ever duplicate code. Never ever duplicate code. Okay, we are able to, the reason we are doing inheritance is that we want to implement these properties. Okay, that means arithmetic op, in arithmetic op, we want to implement these two properties without copying and pasting it here. Okay, I can copy and paste and don't use inheritance. But the problem of duplicating code, never duplicate stuff. Why? The problem is tomorrow if you have to make any changes, if you have multiple copies, you don't know how many copies you have, and you don't know how many times you have to change. For example, if you are maintaining, let's say phone, these days nobody maintains phone book, right? Everybody has details in their phone. But let's say if you are maintaining a diary of phone numbers, okay, it says do not have multiple copies of diary. Why? Because tomorrow if you have to add somebody's phone number, or you have to delete somebody's phone number, or you have to edit somebody's phone number, you will need to know how many copies of phone book have you created. Of course, reading is easy. You create 10 copies and put it in 10 different places. Bedroom, hall, kitchen, everywhere, in your car, everywhere you put. It becomes easy to go and read the numbers. So when you're just reading it, creating multiple copies is easy. And that's what happens in data warehousing. Okay, you create multiple copies, you can read them. But if you want to edit it, okay, in normal database concept, we do not duplicate, because then if you have to add somebody's name, you need to remember, oh, how many telephone directory or diary I have? 10. Where are they? You have to go and add all of them, because if you miss to add, then one of the diary or two diary, the one that you have missed to add, does not have latest information. And when you try to read that diary in case of the need, you will not be able to find that person's phone number, isn't it? So we should not create multiple copies. Always have single copy. It's very efficient to use. Multiple copies is problematic, right? So now in this case, okay, that's why I could have copied and pasted. But tomorrow, if your code for square changes, square root changes in business, things keep changing, right? New requirements come and you'll have to change the existing information. In that case, you'll have to go, you have to know how many places you are adding, how many places you are, editing. You need to know. So what we do, we create one copy of everything. Okay, so without copying and pasting, without adding this here, we are able to access this. Now, luckily, we are using same variable name, but it's not mandatory to use same name, right? Here, since it is only one, they might use just N1 or N, right? Not even N1. Okay, now when you try to run, it gives you error. So it is able to call, but the problem here is that the variable names are different. Variable names are different. So we have to put one additional step here. Since we know that we are using math op, we should be able to call math op init to make sure the data is initialized. Are you with me? Okay. So the question is, how do we call it? So you say here math op dot init and you pass n1. So now, oh, sorry, not here. Here in the init, right? Because init is called automatically, correct? So in the init, you are saying math op dot init. So what happens? This n1 goes to math init, and so now your math of n gets the value n1. Uh-oh, missing one required question. So yeah, you have to give self here. My mistake. Okay. So self will go to self and then n1 and take n1. So now you see here, you got 400 and square root of 20 is 4.4. Square of 20 is 400. So this is because when you are creating object of arith op, automatically init is called, and automatically init will call the init of math and initializing n1 to n. So now, problem is solved. So if you are creating this as derived class of math hub, have this extra step. Make sense? So this is how your inheritance work. Okay. So now if I take you to Paint to talk about what we have done. So what we just did is called simple inheritance, SI, simple inheritance. Okay. So we had a base class, right? We had a base class. Base class was math op, correct? And then we created a derived class here. We created a derived class, which is arith op. Okay. So we generally indicate like this. Okay. So this is parent class or the base class, and this is your derived class or child class. Now you can have any number of base class and derived class. So that means I can have one more here, parent class, and I can have, okay, I'm trying to rotate it. No. So instead, let me use this one. Let me use this. Better. Okay. So you have another class, right? I call it as B2, let's say. So, okay. So you can have, so to, how do I link it to both the parent class? I will say arith op slash math op, the way we did it, comma B2 in the bracket. Okay. So if I go back to our screen here, programming screen, and if I add another class here, class B2, okay, and I will simply put one init function here called def init. Okay, and I will not put anything in it. Print B2 is initialized. Okay, so B2 is okay. So simple. Okay, B2 with B2 initialized. Now, right now, arithmetic has only one parent class. I can say math of comma B2. Now, B2 also becomes parent class of arithmetic op. Okay, nothing happened. Now, let's say I add a function here called def B2 output. Okay, and I will say here print okay, so I'll say here output from B2. Okay, now when I run it, of course, nothing will happen. I have to call B2, right? Now, since B2 is parent of arithmetic of base class of arithmetic of, I can call A1 dot, okay, B2 output. Okay, and B2 output has a print statement, right? So see, output from B2. Makes sense, isn't it? Okay, so you can have any parent class, any number of parent class, any number of parent class. You can have any number of child class. I can have one more class here, now one more class here, one more class here. Now, if I link like these, okay, these two as parent, and now I say, what am I doing? Okay, so I'll call this as C1, C2, C3. So I have a class, derived class called mathop, arithmetic of. Arithop has two parent class, mathop and B2, and it has three children, right? Three derived class, C1, C2, C3. Correct? Three derived classes. So C1 will inherit the properties of this, isn't it? Because this is the parent class. Now, since this is inheriting the properties of these two, C1 will have access to all the three properties. C2 have access to all the three properties. C3 will have access to all the properties. Did you understand? Okay. So for C1, it only bothers, it only needs to know arithop. Since arithop has both of these properties, C1 also will get all the properties. Okay, this is called inheritance. And when you have only one base and one derived, which is simple inheritance, this is complex inheritance. Okay, you have multi-level, multiple means you have more than one parent, at least two parent. Multi-level means you have like, this is your level 1, right? 1, 2, and this is your 2, right? So you call them as multi-level, multiple, okay? But the concept remains the same. Concept remains the same, okay? So we are creating parent and derived classes. All of them will inherit what we have just said. So so far we have only spoken about inheriting the properties from parent class, correct? So let's stick to that. There are a couple of more things that we need to understand here. Okay, so I will go back to our program again. Now you have something called as we added here B2 output, right? So instead of B2 output, I will say class output, okay? Class output. So of course, here also you have to change to class output, right? B2 output is not there. So you got class output, it says output from B2. Now, what this fellow says, which fellow? The derived class. Arithmetic op says No, I want to have my own class output. He said, very well. You can have your own output. Nobody is stopping you. It's like this. When you do not have your own car, you can borrow your parents' car. But if you have your own car, if you have your own property to class output, okay, this is arith op, right? When so now you see class output is in the derived class also and parent class also. Same functionality is there in derived class also and base class. Okay, base and derived class both, right? So when we call this, now it's a confusion, right? Will it call arithmetic op or will it call B2 class? So funda is very clear. If you have your own stuff, then you will not borrow even from your parents. Okay, so in this case, this class that we're talking about A1, I'm talking about A1, right? So it's with reference to A1. Arithmetic op has its own class output. So it is not worried about other parent class. Okay, so if the function or the class that you're talking about, okay, has its own property, then it will not look for parents' property. So you see, you get arithmetic op, right? Now, if I make it something else like class output 1, then, okay, then if you call class output, it knows that I have to call from B2. Now, let's say, okay, it so happens that all your parent class have this. B2 also has it. And let's say math also has it. Okay, now this is your math op, correct? So now it has two parent, right? Arithmetic op has two parent, okay, math hop and B2, and both of them have this class output function or method. Now, if I call arith dot class output, which one will be called? Okay, so you see this. It calls math output. Why? Because here we are saying math of first and then B2. So this is the first parent, this is the second parent. It will go and check in the first parent. If it finds there, it will give you that property. But if it doesn't find there, then it will go to B2. Okay. Now, if I change the order here, if I say math op here after B2, I'm saying B2, comma, math op. Now you see, it took from B2. It took from B2. You can have another class. Okay, now I'm creating multi-level. Multi-level means I'm creating class super op. Okay, super op, and let me copy things from B2 itself. Okay, so it has class out. I'll say super op. Okay, so I'm saying math op. So super op is super class or parent class or base class of math op. Okay, so math op, so super op is independent class. Math op is child class of super op. And of course, our arith op is child class of math op, correct? Now, when let's say all of these, I'll change the name. Okay, class of, now, okay. So now see, now when you run it, class math hop does not have class output 1. We made it to class output 1, right? So it does not have class output. So it pick from B2. Now, if I go and change B2 also, I change this, where is B2? B2 is here, right? Now, none of the parent of arithmetic op. Arithmetic op B2 does not have class output, and this also class output is not there. I have renamed it, right? Okay. So still it's going to work because super op is parent of arith op. So it knows, okay, I will go and get, it's like, second level or grandfather, right? So it's getting data from grandfather. because there is a chain, okay, arithmetic op knows that math op has a parent. So if math op is not able to give, it will go and check with the parent or the base class of math op, which is super op, and it gets the value from here. Now, if super op also doesn't have, okay, super op also doesn't have, now there is no way to access class output. It says, sorry, you do not have access. Now it gives you error. Okay, so we'll stop here today. Today we're talking only about how to access parents' properties. Okay, which is more like your inheritance, right? So this is how inheritance is. Okay, I want you to practice the examples that are there in the book. Please practice those. First, practice this to get hang of it. Practice from book, and you'll be able to get this. Tomorrow, okay, when we meet, we will talk about few more properties similar to this. Is that okay?